In this video, I discuss few more examples on mesh analysis. Determine the power dissipation in 4 ohm resistor of the circuit shown by using mesh analysis. This is the circuit given to us. In previous lecture, we have seen the procedure steps. Step 1 is to identify the number of meshes. Step 2 is to assign mesh currents. Step 3 is to write KVL equation for each and every mesh. Step 4 is to solve the KVL equations to obtain the mesh currents. We follow the same steps now. Step 1. Identify the number of meshes. So number of meshes equal to. Here we can see here I'll consider this as one mesh, this thing as second mesh, this as third mesh. And I will assign the currents as I1. I'm assuming in clockwise direction. I2. You can assume even in anti-clockwise direction. I3. Okay. So step 2 is assigning mesh currents. I1, I2, I3 or the assigned mesh currents. Next, step 3 is write KVL equation for each and every mesh. So applying KVL to loop 1 or mesh 1, we can write here. Always current flows from higher potential to lower potential. So we can write this equation as 5I1. In 3 ohm resistor, two currents are flowing, I1 and I2 in reverse direction. So we can write the voltage drop across 3 ohms is 3 into I1 minus I2 equal to 50. So I can rewrite this equation as 8I1 minus 3I2 equal to 50. Let this be equation number 1. Next, applying KVL to loop 2. If you apply KVL in loop 2 we have 3 resistors, 3 ohm, 2 ohm and 4 ohm. Let us start with 3 ohm. In 3 ohm, two currents are flowing, I2 and I1. While writing KVL equation, you should consider the current flowing in that loop is greater than the other currents. So 3 into I2 minus I1 plus 2 I2 plus 4 into I2 minus I3 equal to 0. We can rewrite this equation as minus 3I1 plus 9I2 minus 4I3 equal to 0. Let this be equation number 2. We have one more mesh. We should write KVL to loop 3 as well. Applying KVL to loop 3. Loop 3 has two resistors and one source. In 4 ohm resistor, two currents are flowing, I2 and I3, which are in reverse direction. Voltage drop across 4 ohm resistor is 4 into I3 minus I2 plus 6 I3 plus 10 equal to 0. I can rewrite this equation as minus 4I2 plus 10I3 equal to minus 10. Let this be equation number 3. We are done with step 3 and step 4 is solve the KVL equations to obtain mesh currents. So solving equations by solving equations 1, 2 and 3, we will get values of I1, I2 and I3. Using calculator, I got I1 equal to 7.13 amp and I2 equal to 2.325 amp and I3 equal to 0.059 amperes. Okay, these are the three current we got. What is the question? Determine the power dissipation in the 4 ohm resistor. So this is the 4 ohm resistor. We should find the power dissipated in this resistor. So power dissipated in 4 ohm resistor is given by I square R, because we know power equal to V into I. If you substitute in place of VIR, we'll get I square R. The current flowing in 4 ohm resistor is I2 and I3. If you see the figure, the current flowing in 4 ohm resistor is I2 and I3. So you can take either I2 minus I3 or I3 minus I2, because we are going to use here square. So I will take this as I2 minus I3 whole square into R. So I2 we got 2.325 minus of minus 0.059 whole square into 4. If you solve this, you will get 23.23 watts. This is the answer. Let's discuss next example. Determine the voltage V which causes the current I1 to be 0 for the circuit shown. Use mesh analysis. Here I1 current is not shown. We have to assume, okay, if this is 0, you have to find the voltage V. In mesh analysis, step 1 is to identify the number of meshes. So this is mesh 1, this is mesh 2, and this I am assuming mesh 3. This is 2. Okay, so number of meshes equal to 3. Next, step 2, assign mesh currents. I would like to assign the mesh currents as I1, I2, I3. So I1, I2, and this is I3. And step 3 is applying KVL equation to each and every mesh. So let us start it. Applying KVL to loop 1. I can write the equation as here. Voltage drop across 6 ohm resistor is 6 into I1 plus voltage drop across 2 ohm resistor is, here two currents are flowing, I1 and I2. I'll assume I1 is greater. So 2 into I1 minus I2. Next 5 ohm resistor, 5 into I1 minus I3. Next plus V equal to 20. By rewriting this equation, I can write 6I1 plus 2I1 plus 5I1. That is 13I1 minus 2I2 minus 5I3 equal to 20 minus V. Let this be equation number 1. Next, applying KVL to loop 2. Voltage drop across 2 ohm resistor is 2 into I2 minus I1. Voltage drop across 3 ohm resistor is 3 into I2. Voltage drop across 1 ohm resistor is 1 into I2 minus I3 equal to 0. I can rewrite the above equation as minus 2I1 plus 2I2 plus 3I2 plus 1I2. 6I2 minus I3 equal to 0. Let this be equation number 2. Applying KVL to loop 3. I'll start with 5 ohm resistor here. 5 into I3 minus I1 plus 1 into I3 minus I2 plus 4 into I3 equal to V. I can rewrite the equation as 5I1 minus I2 plus 10I3 equal to V. Let this be equation number 3. We are done with applying KVL to each and every loop present in the circuit. Next, we have to solve for I1, I2, I3. In the question, it has been given that I1 is already 0. So we just apply that logic here. Substitute I1 equal to 0 in equations 1, 2 and 3. Then the equations becomes equation 1 become minus 2I2 minus 5I3 equal to 20 minus V. I will take this as equation number 4. Equation 2 becomes plus 6I2 minus I3 equal to 0. I will take as equation number 5. Next, third equation minus I2 plus 10I3 equal to V. Equation number 6. By solving equations 4 and 6 and 5 and 7, now I just want to rewrite equation number 5 as here minus and here plus. Now adding equations 4 and 6, we will get minus 3I2 plus 5I3 equal to 20. Let this be equation 7. Then solving equations 5 and 7, we will get I2 equal to 0.74 amps, I3 equal to 4.44 amp. Okay, by substituting the values of I2 and I3 in equation 4, you can see equation 4 here. You can see equation 4. If you substitute the values of I2 and I3 in equation 4, you'll get the value of V. We'll get V equal to 43.7 volts. We'll get voltage equal to 43.7 volts. This is the answer. That's all for this video. Thank you.